We very often help our customers, sometimes remove grams or even kilos in weight from their vehicles. But in this instance, they didn't just want to remove kilos, they wanted to remove tons.
Lightweight, modularity, composite materials. You probably don't think about rail vehicles when you hear these attributes. Hi, I'm Martin. The TDI Rail guys had exactly these attributes on their mind when they designed the very light rail vehicle. I recently met Stuart and we discussed about this interesting project. So keep watching.
TDI, or Transport Design International, are a pioneer in mobility solutions, and they focus really on lightweight innovation for the market, and on top of that they also focus on zero emission propulsion systems.
What if the train you took every day could be cheaper, lighter and more environmentally friendly? What if you could escape the traffic congestion of the roads and make the last few miles of your journey easier? The Revolution Very Light Rail project is developing a lighter, cheaper, passenger-friendly transport solution capable of providing local rail services to connect into the intercity network.
What was actually the motivation for TDI to engage in that project?
We very often help our customers, sometimes remove grams or even kilos in weight from their vehicles. But in this instance, they based their ambition on producing a similar size train to a Class 153. But they didn't just want to remove kilos, they wanted to remove tons.
Oh wow, that's ambitious.
It was an extremely ambitious project, so straight away this heightened my attention and it sounded extremely interesting. So talking to the team there, they started to explain about what this means and why they want to remove so much weight. And there's a few benefits to this. The obvious one with lightweighting, of course, is less energy consumption. So this is a sustainable approach to mobility in these days. But I guess another one of the things that I didn't really understand at the time, but now understand more, is being able to use lower profile tracks when building these urban mobility systems.
What does that mean?
Well, when you build in a city, for example, or with metros or tram networks, most of that cost in the infrastructure is really related to taking those utilities that are already there, like electricity, gas, and water, and you then have to push this down. So then you can build all the reinforcements required to transport very heavy vehicles and lots of people around in the cities. The twofold project that TDI had was really focused on, one, developing a really lightweight vehicle, but two, then developing this very low profile track system.
Oh, well, I guess, if you think about that, what it means, a lot of construction work and of course then a lot of higher costs. So I guess this was a good selling argument for them as well.
Yeah, it was a really interesting part of the project.
Yeah. Actually, I guess they couldn't really use standard materials to get that dramatic amount of a weight reduction. So what kind of materials did they use to achieve this goal?
So looking at the full construction of the vehicle, the base layer of the vehicle, or the chassis, and the bogies, they use steel. This is pretty commonplace. It's a strong and durable material, and we all know the topic of durability is really important in the rail market. But outside of that, when you start to look further up the vehicle, you then have composites being used for the side panels in the vehicle. You've also got aluminium structural components being used in the roof and up the sides. So this is where TDI were really able to achieve a lot of this mass reduction in what they were trying to do.
If you think about that, in automotive we also hear about this, right? They use a lot of, actually a wild mix of different materials, and that actually leads me also to the next question. I guess there were some challenges and consideration in that regard in terms of adhesive selection, and probably also some factors specifically to consider.
Yeah, so one of the things that TDI did, which I thought was important as well, is not only are they looking at sustainability from the point of producing a lightweight vehicle, but it's how that vehicle is also produced. So one of the things they did is with the composite material, for example, they utilised biodegradable resins. Now this, on one hand, is great. They were locally sourced as well, so even the transportation of these materials is having less of an impact on our environment. But the other thing to consider here is when it comes to what we do and how we then bond products, you know, we have our usual challenges, but then when you start to consider these rather exotic materials, you know, things like adhesion and other topics that are important to us really come into play. So we really had to figure out not only what the material selection was going to be to manage the construction of the vehicle, but also to really understand how we're going to get ultimately these things to stick together.
Yeah, absolutely. And I guess this can sometimes really be challenging. You know, certain materials are easier to bond than others. Depends a lot on the polarity of the products. But that leads me actually also to the next question. What did we actually use to fabricate this train?
Yeah, this is where the wide portfolio of Sika's products really comes into play. We have so many opportunities and so many different products that we can use in our technology mix, and what we're able to do with that is really break the applications down into three key areas. You have your glass bonding, something Sika is widely known for. You have your mixed material bonding, and then you also have your structural bonding element of the build. So with the glass product, you know, this is sometimes a standard approach, but we took a slightly different approach here with our PowerCure solution. Now PowerCure, just briefly, is a one-component polyurethane system, but with a booster included. So utilising a PowerCure product allows people to get more utility out of their vehicles and less downtime. So there's lots of benefits to be taken from that system. So the solution that we found ourselves having to really get some technical support within the UK, and I'll touch on that more, but the PowerFlex product range that we have is a two-component polyurethane system. And there's a couple of benefits here with that product as well. The PowerFlex material itself has some inherent flexibility to it, even though it's a structural bonding product. So when you're looking to bond things like composites to aluminium structures, you know, one of the considerations there is these coefficients of thermal expansion between these two materials. So when you have a train sat in a shed, for example, at room temperature, and then it goes out into a winter's day, those temperature changes can be quite dramatic and can put some stress into the structure. So using something like our PowerFlex products really helps in that area. And then onto the third topic of structural bonding. You know, Sika is well known for structural bonding in the automotive market, and maybe not so much in our industrial transportation sector. But we've got some really, really nice products, and one in particular is our SmartCore technology. Now, this material was used by the guys at TDI to really reinforce some of their mechanical joints within the vehicle. And again, back to that topic of durability, this will play a key part in making sure that those vehicles not only are strong on day one, but you know, 20, 30 years down the line, when they've had their time out on the tracks, they'll still be strong and durable and safe.
Yeah, I mean, now you know, it sounds pretty complex. And I think, I mean, or I guess there was a lot of support needed to, you know, to validate all these different solutions. So how are you able to provide all that support, which is required apparently, because, I mean, they have high standards in rail.
Yeah, they do. And, you know, we pride ourselves on being a global business, and we are. But actually, the thing I really pride myself on is being local and local to our customers. Now, on top of the support that we give commercially to these customers, we also gave a lot of technical support to TDI. So, you know, back to that composite material, this exotic surface that maybe we're not so used to, our technical service team in the UK did a great job of analysing this material, really trying to understand how it functions and how our products would work with it. And, you know, on top of all of that, once we've developed a system and a solution to this, we then go and see the people who will ultimately build these vehicles, and we support them with training, utilising our technical guys to go in, work hand in hand with them to develop those processes. You know, it's important for us to make sure that that same process is maintained throughout the build, and our technical team in the UK did a fabulous job of making sure that the guys were fully aware of what they needed to do and gave them the tools to make a success of what they tried to do.
Yeah. Sounds like a very exciting project. And maybe, you know, you're a little bit confused about these different technologies, so no worries. Reach out to us, reach out to your local Sika representative, and you can find out more about it. So we saw lower track profile, total cost of ownership are very important factors when we talk about investments, and I think TDI Rail tackled that very well. I hope you found that interesting. If you want to see more, keep watching our program Better Made with Adhesives.